Hello, my name is Polakit Paskonchalat. Today we are going to talk about recurrent neural network. Our outline today will cover the fundamental concept of neural network. Next, we will develop our understanding to recurrent neural network or RNN. Finally, we will learn how it's be used in the real world situation or the application and example part. Neural networks are type of machine learning algorithms that are designed to recognize patterns and relationships in data. They are modeled after the structure and function of human brain with layer of interconnected nodes or neurons, which process and transmit information. In a neural network, there are typically three types of layer: input layers, hidden layers, and output layers. The input layer receives the initial data, which is then processed by the hidden layer, with each layer applying a set of mathematical functions to transform the data. The output layer then produces a prediction or classification based on the input data. Now let's move on to our main point. A recurrent neural network or RNN is a type of neural network that is designed to process sequential data where each input data point has temporal relationship with the previous data points. RNN could maintain an internal state or memory which enable them to process sequence of arbitrary length. The main difference between a standard feed-forward neural network and an RNN is that the RNN has loop within its architecture, allowing it to process information over time. In an RNN, each neuron is connected to itself in the previous time step, creating a feedback loop. This allows the network to remember previous inputs and use them to influence the output. Here is the sample structure of recurrent neural network. On the left-hand side, you will see the three main layers, which are input, hidden, and output layers. The hidden layer loop in the red rectangle can expand to full model of sequential calculation which share the weight and bias across all time steps as shown on the right-hand side. Going into the calculation detail, we have sequential input. Let's say it is xt minus 1 to xt plus 1. The xt minus 1 will undergo the weight bias and activation function, and then we will have output, which is the predicted value of yt. However, the data from the first hidden layer will also be used in the next time step, which is t, to generate the predicted value of the next time step. And likewise, it will go through this process for all the data points. So how are we gonna train it? RNN still has the loss function, backpropagation, and gradient descent, but it will be a little different from the feed-forward neural network. As you could see on the right, if we backpropagate the E2 parameter, we have to go through all of the loop because the calculated data C1 to C3 is related all across the hidden layer, and we done it by the chain rule. After that, we can adjust weights and bias to fit the sequential data by gradient descent as usual. This process is called backpropagation through time. So wondering what will happen if it has quite a lot of layers? These will be the two main problems of simple RNN interface. First, the vanishing gradient from the previous slide. We have seen that the deeper layer, the more we must go through the multiplication in order to backpropagate the loss parameter. A product of small value of gradient or less than 1 for many layers will cause the vanishing or zero value. In contrast to exploding gradient problem, calls for the product of large value of gradient, which will result in infinite number. After we understand the concept of recurrent neural network, let's see how this works for real situation. In the example, we have created model to predict how many bicycles will be rented in the following days with the feature like date, season, temperature, humidity, and weather ETCs. Using Kira's library for setting up the simple neural network, RNN. We got the dataset of bicycle sharing in Washington, D.C., which recorded daily for 2 years, starting from importing our dataset, then splitting it into three portions: the training data, which is the largest one, the testing data, and the holdout data, which is about 7% of our dataset. Then we normalize those parameters to reduce the difference in order of magnitude. Next, we created a simple RNN with 4 nodes, single layer, and ReLU activation function for the prediction. Using the previous normalized training data to train the RNN for 3000 iterations, this process is backpropagation to time to minimize the loss function and noting that the data are fed as a sequence of time. Finally, we used testing and holdout data with our recurrent neural network to predict the rented amount of these, and these our outputs. As you can see, it doesn't look so accurate, but overall performance check by using the mean absolute error, it has an accuracy of 86.3% for testing data and 72.2% for holdout data. So that's how the simple RNN works. The more complex and useful models are LSTM and GRU, which can be better studied. Thank you for your attention.